Let's look at this one. Carbon plus sulfur forming carbon disulfide. What's being oxidized? What's being reduced? That's not an ionic compound, right? So we can't look at loss or gain of electrons. And there's no oxygen in there. So we don't yet have the skills to identify what's being oxidized and what's being reduced. So we use something called oxidation states. This helps us to track electrons in chemical reactions even when ions are not being formed. It's like bookkeeping for electrons. So what we do is in covalent bonds, we're going to assign all of the shared electrons to the more electronegative element. So that's the basis behind this, but I'm just going to show you how to do it. So the oxidation state or the oxidation number will be calculated for each element in a compound. So the carbon here has an oxidation state, and over here the carbon has an oxidation state, and each of these sulfurs has an oxidation state. And this sulfur has an oxidation state. Oxidation states are sometimes the same number as an ionic charge, but they are not ionic charges. They just happen to be the same number sometimes. So oxidation states are not ionic charges. So these are the rules for assigning oxidation states. Whenever you spell something out, it starts looking very, very complicated. It's really not this bad. The oxidation state of an atom in a free element is 0. If you have the element by itself, the oxidation state is 0. The oxidation state often ends up being the same as the charge on an ion. Does this have a charge? No, and it's all by itself. It's 0. If we have monatomic ions, calcium ion, the oxidation state is the same as the charge. Here's chloride ion. The oxidation state is the same as the charge. And like ionic charges, all of the oxidation states in a polyatomic ion or in a compound have to add up to the overall charge. So if it's a neutral molecule, all the oxidation states add up to 0. If it's a polyatomic ion, like nitrate ion, then all the oxidation states add up to the charge. So it's a lot like charges, but it's not charges. Group 1 metals are always +1. I really don't think we need this because it's just the charge on those things. The one thing that we need to learn extra here is what about the nonmetals? So table's shown at left. Well, it's not shown at left, it's shown here. So these rules, you start at the top and you go down. And if you've got rules that conflict, you always use the one on top. So this is like an order of who gets their way. Because what would fluorine have as a charge if it was an ion? It would be -1. So in compounds, fluorine often has a -1 oxidation state, even if it's not an ion. Hydrogen as an ion, the one we're familiar with, is +1. Oxygen as an ion is -2. The group 7 elements, other than fluorine, they would all be -1 ions. Group 6 would be -2 ions. Group 5 would be -3 ions. So the way I think of this is the nonmetals want to have an oxidation state equal to the charge they would have if they were an ion. But they can't always get what they want. And so this is the order. Who's in line first? Fluorine's first. Fluorine gets what he wants. Then hydrogen, then oxygen, and then it goes 7, 6, 5. So how do you remember that? Vietnamese noodles. Pho, right? Yummy. Well, what if we just take off a little bit of the P? It says F anyway, right? F. So FHO. FHO 765. I think there's actually a restaurant that's F 76. Right? It just cracks me up. Anyway, so just think of noodles. Now I'm getting hungry. F 765. That tells us who gets what they want. Okay, so let's do some examples. So here we have zinc. There's only the one kind of atom there. What's its oxidation state? It's 0. So zinc here all by itself, does it have a charge on it? No. Oxidation state is 0. Here we've got copper all by itself, but it's an ion. What's its oxidation state? 2+. We actually put the plus first, but that's a minor detail. Okay, so the oxidation state is the same as the charge. So here we have an ionic compound. What are the two ions in there? Calcium and chloride. Those are actual ions. Their oxidation states are just the same as their charges. So the oxidation state for calcium is +2, and the oxidation state for chlorine is -1. Each chlorine has a -1 oxidation state, just like each chloride ion has a -1 charge. There are 2 of these and 1 of those, and all of those add up to 0, which is the overall charge on the compound. CF4. There aren't any ions here, because these are 2 nonmetals. So this is where the oxidation states really come in handy. So F 765. Fluorine, is there fluorine here? Yep. What does fluorine want? -1. So fluorine gets to be what it wants because it's first on the list. It gets to be -1. The carbon has to pick up the slack, make up the difference. So this is a neutral compound. That tells me that all the oxidation states have to add up to 0. I have 4 fluorines, a total of -4 in oxidation states. I only have 1 carbon, so it's +4. This is the same process as identifying charges on ions. Like if this was some metal, that's exactly how we would find the charge on the metal to be +4. So it's the same process, that's why it's easy to confuse them for charges, but there's no charge there. These are oxidation states. Any questions about that one? Each atom has its own oxidation state. If you have multiples of the same atom, I mean, how would you decide that one fluorine has to be -2 and one has to be 0? You wouldn't. They're the same element. They have to have the same oxidation state as the others in that compound. Otherwise, there's going to be lawsuits. Okay, this is the nitrite ion. There's a -1 charge there. We've got 2 nonmetals. So we say F 765. Is there a fluorine? Nope. Who's next on the list? Hydrogen? Nope. Next on the list, oxygen. Oxygen's the winner here. Oxygen gets his first choice of oxidation state, which would be the same as the charge it would have as an ion. So oxygen chooses -2. There are 2 oxygens. So that would give us a total of -4. Overall, this has to have a -1 charge. So the nitrogen is going to be +3. If the nitrogen was +4, it would be NO2, which is a compound, but we want NO2 minus. There's an extra electron there. Any questions? SO3, 2 nonmetals, F 765. No fluorine, no hydrogen, oxygen. Oxygen gets first choice. Oxygen wants to be -2. Sulfur has to make up the difference. +6. Because there are 3 of these guys, they're each -2. So -2, -2, -2, that's a total of -6. This doesn't have a charge, so sulfur has to be +6 so that the oxidation states add up to the overall charge. Any questions? It's like some weird party game. So now we can go back to this chemical reaction here where we couldn't identify what was being oxidized and what was being reduced. We can use the oxidation states to help us figure that out. So what's the oxidation state for the carbon? 0, because it's an element by itself. How about this sulfur? Is it an element by itself? Yeah, there's 2 moles of it, but it's still just sulfur. CS2, 2 nonmetals, Fe765. No fluorine, no hydrogen, no oxygen, no group 7. Group 6 is the first thing we come to that's there. So the sulfur's in group 6. What does it want to be? If it was an ion, what would its charge be? -2. So the sulfur has a -2 oxidation state. There are 2 of them. So what's the oxidation state on the carbon? +4. So now we can look at the change in the oxidation state. So the carbon went from 0 to +4. If those were charges, that would be oxidation, right? An increase in oxidation state is oxidation. The sulfur went from 0 to -2. If we were looking at charges, that would be reduction, right? Reduction is gain of electrons. Reduction is a decrease or a reduction in the oxidation state. So oxidation is an increase in the oxidation state. Reduction is a decrease in the oxidation state. Any questions? Use oxidation states to identify the element that's being oxidized and the element that's being reduced. So when we look at the reactants here, there are 2 reactants, but this reactant has 3 different elements in it. We look at the elements individually. So it's asking for the element that's being oxidized and the element that's being reduced. So what we're going to do is we're going to assign oxidation states. So what's the oxidation state of tin metal? SN. What's its charge? 0. HNO3. Yeesh. Okay, Fe765. No fluorine. Hydrogen. What does hydrogen want to be? +1. And now we've still got nitrogen and oxygen, so oxygen gets its choice before the nitrogen. What does oxygen want? -2. Now, to find the nitrogen, this becomes a little messier, right? So maybe let's actually write this down. So we've got +1 from the hydrogen, and then we've got 3 -2s, 1 from each oxygen. And so when we add all that up, I'm getting -5. So the 1 nitrogen then must be +5. Okay, so we did all the reactant elements. Now let's look over here. SNO2, that is an ionic compound. Just use ion charges. What charge does oxygen have in ionic compounds? -2. So the oxygen's -2. And what's the charge on the tin? There's 2 oxygens, and they're each -2. So that's a total of -4. so it must be plus 4. Here we have NO2, Fe765. Fluorine, nope. Hydrogen, nope. Oxygen. Oxygen gets to be minus 2. What does the nitrogen have to be? Plus 4. The coefficients here have nothing to do with it. You're just looking at the compound formula. Here's H2O, Fe765, no fluorine. Hydrogen gets what it wants. It wants to be plus 1. There's 2 of those, so what does the oxygen end up being? Minus 2. They both got what they wanted. Nice. So any questions about that? Now we're going to look and see what changed in oxidation state. So the tin was 0 here, and it's plus 4. So that one changed. Right? So the tin went from 0 to plus 4. Is that an increase or a decrease in oxidation state? It's an increase. That's an oxidation. So this was oxidized. So let's look at the hydrogen. Here's hydrogen, it's plus 1, and over there it's plus 1. It did not get oxidized or reduced. Here's the nitrogen, it was plus 5, and over here it's plus 4. That's different. That went down, right? Reduction. So the nitrogen was reduced. Here's the oxygen, minus 2. Over here there's oxygen all over the place. Minus 2, minus 2, minus 2, nothing happened to the oxygen. So the tin is oxidized, the nitrogen is reduced. Any questions?